Current-carrying coil in a magnetic field. By the end of this lesson, you should be able to explain the factors that affect the magnitude of the force on a current-carrying conductor in a magnetic field. Describe how a current-carrying coil in a magnetic field experiences a turning force. Stronger forces are required to drive motors of large machines such as washing machines, refrigerators, and electric drills. Smaller motors are used in electric fans, disk drives, and toy cars. How can the magnitude of the force be changed? What are the factors that affect the magnitude of the force? A conductor AB connected to a direct current supply is placed in a magnetic field. Initially, the switch is switched off. Predict the direction of the motion of the conductor AB when the switch is switched on. How do you determine the direction of the motion of the conductor AB? Click on the switch to check your answer. The conductor AB will swing to the right. According to the Fleming's left-hand rule, the direction of the magnetic field is from north to south. The direction of the current flow is from B to A. Therefore, the direction of the force is to the right. What can you say about the size of the swing of AB if the amount of current passing through AB is varied? Drag the slider of the rheostat to find out. As the current increases, the swing is bigger, and vice versa. What can you say about the size of the swing of AB if the strength of magnetic field is varied? Click on the Strength of Magnet and Power Supply button to find out. As the strength of the magnet increases, the swing is bigger, and vice versa. What can you say about the magnitude of the force on the conductor when the current and the strength of the magnetic field is increased? As the current and the strength of the magnetic field increases, the swing is bigger. This indicates that as the current and the strength of the magnetic field increases, the magnitude of the force also increases. What can you say about the magnitude of the force on the conductor when the amount of current passing through AB and the strength of the magnetic field are decreased? As the current and the strength of the magnetic field decreases, the swing is smaller. This indicates that as the current and the strength of the magnetic field decreases, the magnitude of the force also decreases. Thus, what are the factors that affect the magnitude of the force exerted on a current-carrying conductor in a magnetic field? The magnitude of the force exerted on the conductor depends on the amount of current that flows in the conductor and the strength of the magnetic field. A rectangular current-carrying coil is placed in the magnetic field of a set of permanent magnets. What will happen to the coil when placed in a magnetic field? Look at the cross-sectional view of the current-carrying coil in a magnetic field. When current flows through the wire, a magnetic field appears around it in the form of concentric circles. Determine the magnetic field direction for wire segment AB and DC. The direction of the magnetic field lines of the wire can be determined by using the right-hand grip rule. When the magnetic fields of the two current-carrying wires interact with the magnetic field, forces are resulted. Determine the direction of force on wire segments AB and DC. The direction of force on the current-carrying conductor in a magnetic field can be determined by using Fleming's left-hand rule. When the magnetic fields of the two current-carrying wires interact and combine with the magnetic field of the permanent magnets, a catapult field is formed. The wire segment AB experiences a downward force, while wire segment DC experiences an upward force. As a result, two equal but opposite forces are exerted to each side of the coil. These forces resulted in the turning effect of the coil in the clockwise direction. What will happen to the direction of the rotation if the polarity of the magnets is reversed? The direction of rotation of the coil will change. What will happen to the direction of rotation if the direction of the current flow is reversed? The direction of rotation of the coil will change. A moving coil meter can be used to measure direct current. It consists of a rectangular coil of fine insulated copper wire which is able to rotate in a strong magnetic field, a curved magnet, a pointer, a linear scale, control springs, and a soft iron cylinder. The coil is pivoted on a bearing, and its rotation is resisted by hair springs, which act as control springs above and below it. Current enters and leaves the coil via the two control springs above and below it. The soft iron cylinder at the center of the coil is fixed, and together with the curved poles of the magnet, it produces a radial field. When current flows through the coil, an elastic field is created as a result of the interaction between the two magnetic fields. This produces a pair of turning forces acting on the coil. The turning forces cause the coil to rotate until stopped by an equal and opposing force on the coil by the springs. The greater the current, the greater the deflection shown by a pointer attached to the coil. Hence, the meter has a linear scale. The sensitivity of the moving coil meter is increased by having more number of turns in the coil, stronger magnets, weaker control springs, a greater number of turns in the coil. A current-carrying coil is placed in the magnetic field of a set of permanent magnets. Predict the direction of current flow from the direction of the rotating coil. Click on the Start button. If the rotation of the coil is anti-clockwise, what will be the direction of the current flow between points A and B? Hint: use the Fleming's left-hand rule. The direction of the magnetic field is from north to south, which is from left to right. The force exerted on the left side of the coil is downwards, and the force exerted on the right side of the coil is upwards. By aligning the Fleming's left-hand rule, the direction of the current flow can be identified. A conventional current flows from the positive terminal to the negative. Therefore, point A is positive and point B is negative. What is the direction of rotation of the coil if the direction of the current flow is reversed? When the direction of the current flow is reversed, the rotation of the coil will also be reversed, that is, in the clockwise direction.